Okay, geometry. Today we are going to be continuing our journey into proofs by looking at congruence properties, and we are going to start just with segments. So over the last week we looked at the concept of proof with Uno cards, and then we went back to Algebra 1 and we were able to solve some equations, only we did it a little bit more rigorously by using some proof methods. Well, today we're going to start getting into actual geometry proofs. So we need to talk a little bit about congruence. So when do we use congruence versus when do we use the equal sign? So we only want to use the equal sign if we are dealing with numbers. Things like the distance formula. If we want to find the distance between 2 points, that would be a number. That would be something that we want to use an equal sign with if we're comparing distances. If we're talking about the degree measures of anything, any angles, then we could talk about the equal sign if they're equal angles. Or we could talk about things like the lengths of segments. Those would be equal to each other. We want to use the congruence sign when dealing with objects. So we can talk about segments, angles, or triangles, and other things that are congruent to each other. So we are actually talking about physical objects on the Euclidean plane, and those are going to be congruent to each other because we're not talking about numbers. I'm talking about things like segment AB is congruent to segment CD. Or I could say something like triangle LKJ is congruent to triangle PQR. So we're talking about actual objects there. So let's jump in and let's get some properties of congruence here. So up here at the top, we've got our properties of equality, and then let's add some of these properties of congruence. And notice reflexive, symmetric, and transitive are all in our properties of equality also, and they're going to work the exact same way when we're talking about congruence. It's just that we're now talking about actual objects instead of numbers. Okay, so the reflexive property of congruence says that for any segment AB, then we can say that, and I'm going to use a few tools here in Cami. If I go ahead and type seg, that will get me segments here, and I'm just going to click that to get that on my list of things that I use. So notice that my segment tool is right here. And the other one I'm going to use a lot today is congruence. So I'm just going to type CON, and I've got a congruent and a not congruent right here. I'm just going to use the congruent right now. So now I've got those tools kind of ready to go in my toolbox. And anytime you want some kind of symbol, just type the first few letters of what you want, like DEG for degree or ANG for angle. INF if you need to use infinity for some reason, then it'll pop up and you can put it in your quick list right up here. Okay, so for any segment AB, the reflexive property of congruence tells us that segment AB is congruent to segment AB. So we're saying that if two segments are exactly the same, or it's the exact same segment, then yes, that same segment is congruent to itself. And believe it or not, this actually does come up a lot. So it's something that we want in our back pocket. Okay, the next property we have is the symmetric property of congruence. And this works just like the symmetric property of equality did. So the symmetric property of congruence tells us that if segment AB is congruent to segment BC, or not BC, I guess I could use BC, but I'm going to use CD, just have 4 different letters. So if segment AB is congruent to segment CD, so we've got 2 different segments congruent to each other, then segment CD is also congruent to segment AB. So that should make sense. It's just like the equal sign. If we're congruent one way, then we're also congruent the other way. The congruent sign is very similar to the equal sign. And then finally we have the transitive property of congruence, which also works exactly like it did with the transitive property of equality. So if we've got segment AB is congruent to, let's use PQ this time, to segment PQ, and so this is a statement with two conditions here. Whoops, wrong button. And segment PQ is congruent to segment XY. So we've got two statements here. We've got AB is congruent to PQ and PQ is congruent to XY. Then what the transitive property of congruence tells us is that segment AB is congruent to segment XY. So just like with equality, we are able to transition here. So we've got this PQ kind of dealing as a bridge, and it allows us to transition from AB to XY. So we have the transitive property of congruence. Okay, let's talk about definitions, because remember, properties, definitions, theorems, and postulates are the reasons that you're going to be able to use in any proof. So we are going to throw some definitions out here. So we've got the definition of congruence. So segments are congruent, I should say congruent, not congruence, if and only if they have the same measure. So this if and only if means that this condition goes both ways. So that's actually very useful for us. So that says that if the measure of segment AB is equal to the measure of segment CD. So notice I use the equal sign because we're talking about measures, so we're talking about numbers. But if this fact is true, then segment AB is congruent to segment CD. So this is actually a very useful tool here, because it will allow us to go back and forth between numbers and objects, which we're going to need to do sometimes. And then same thing here, if segment AB is congruent to segment CD, so this is the flip side of this conditional statement, biconditional statement. So if segment AB is congruent to segment CD, then the measure of segment AB is equal to the measure of segment CD. So it goes both ways here. We're able to use the definition of congruence to go between numbers and objects. We've also got the definition of a midpoint. So if M is the midpoint of AB, so let's just go ahead and let's use that color instead. There we go. So let's say we've got point A, point M, and point B here. So A, M, B. All right, so this is what our diagram looks like. This is what this definition is telling us. It tells us that if M is the midpoint of AB, then what we can say is AM, segment AM, is congruent to segment MB. So we're able to use that midpoint to prove congruence, just like we were able to use the midpoint to use some equal signs in there. Okay, and then finally, last one here, we do have a postulate that we've seen before, but it says the segment addition postulate, and we're just going to put this in terms here because this is a reason that we're going to use in proofs, but this is one with the equal sign. So if A, B, and C are collinear, they're all in the same line, and B is between A and C, then we can say that the measure of segment AB plus the measure of segment BC is equal to the measure of segment AC. So we've seen that before. We've actually used that in Unit 1, but now we're just putting it down here on our reference here to be able to use it in proofs. Okay, so I am going to post this reference sheet on Classroom, so keep an eye out for that. And then your homework, your classwork, I guess I should say, is going to be to do this 1 through 12 here. So like number 1, if we've got PQ equal to PQ, we're talking about distances, then segment PQ would be congruent to segment PQ. So number 1, I'll give you a freebie here. That is our definition of congruence. So you're just going to be filling out 2 through 12 here the exact same way. And that's all I've got for you, and I'll see you in class.